Hello once again, everyone. This is Mr. V. Hill. Today we're talking about systems of equations and solving them by elimination. So again, we're just going to go through a quick example here. We got this system that we want to solve. 2x plus 3y is equal to 8, and 3x minus 5y is equal to negative 7. Now the basic idea behind this elimination method is that we're going to add these two equations together. Not really, because you can't add equations, but we could add this side of this equation to this side of this equation, and this side of this equation to this side of this equation. And so if this thing is equal to this thing, and this thing is equal to this thing, then this thing plus this thing should equal this thing plus this thing. Make sense? Hopefully so. Went kind of quick with that. But we're going to do this in a clever way. Because right now, if we add these two equations together, really we're just combining the like terms here. 2x plus 3x is 5x. And 3y plus negative 5y would be negative 2y. So we don't really have any elimination going on. Meaning we want to get rid of or eliminate one of the variables. So we end up with a single equation in a single variable or a single unknown. So we're going to do a little trick here. So I'm going to rewrite my system down here just so I can show you the whole spiel. 2x plus 3y is equal to 8, and 3x minus 5y is equal to negative 7. Here's our system. What I'm going to do is I'm going to multiply both sides of the first equation by 3. And I'm going to multiply both sides of the second equation by negative 2. And you're going to see what's going to happen here. So when I distribute in on both of the equations, we're going to rewrite the whole system again now. 3 times 2x is 6x. 3 times 3y is 9y. And 8 times 3 is 24. That's our first equation, rewritten now after this MPO, or multiplication property of equality. The second equation, negative 2 times 3x is negative 6x. Negative 2 times negative 5y, that's going to be a 10y. And negative 7 times negative 2 would be 14. So there's our system rewritten now. But look at what's going to happen now when we add the two equations together. We just add straight down. 6x plus negative 6x, oh, that's 0. So these x's are going to be eliminated. So that's the whole point of this. And when you're doing this elimination method, the equations don't have to be in standard form, but it's nice if they are. We just need x's on top of x's, y's on top of y's, constants on top of constants, and of course equal signs on top of equal signs. But other than that, we can jumble these up however we want. But standard form is kind of a nice way of doing that. So this first little trick that we're doing is we're going to multiply the equations by whatever we need to. So that elimination will happen. Basically, what we need is the coefficient of x or y, it doesn't matter, we can eliminate the y's too, but here the coefficient of x is 6, the coefficient of x down here is negative 6. They're opposites. So when we add them together, the x's go away. Then all we do here is now we're going to add the equations together. Really what we're doing is an addition property of equality. We're going to take this first equation, we're going to add the same thing to both sides. We're just going to add this version of the same thing to the left-hand side, and this version of the same thing to the right-hand side, because this thing is equal to this thing. So we just add straight down, combining the like terms as we go. The equal sign on top of the equal sign right here. 6x plus negative 6x, those get eliminated. 9y plus 10y, that's 19y. 24 plus 14 is 38. Now we're down to a single equation in a single variable or a single unknown right here, which we know how to solve quite simply. we divide both sides by 19. So all we do now is just solve. And of course these 19s cancel out, and we get y is now equal to 38 divided by 19 is 2. There's half of our solution, the y coordinate. No big deal. And really, if you think about what's happening here, if you want to do substitution on this system and look at the work side by side, what you'll end up seeing is that the elimination method is really just a shortcut for the substitution method. We accomplish the substitution and combining like terms all in one step. That's all it really is. Okay? But now that we've gotten our y coordinate, now we need to go back and get the x coordinate. So just like with substitution, we take this and we go all the way back up to one of the original equations. Let's do the second equation this time, why not? And we just plug it in there for the y variable in that equation. So we have 3 times x minus 5 times the y coordinate now, which is 2. That's supposed to be equal to -7. And now all we have to do is solve for x. So what we have here is 3x minus 5 times 2 is 10 equals -7. Now we just add 10 to both sides, giving us 3x is equal to -7 plus 10 is 3. Then we divide both sides by 3, and we get x is now equal to 1. And that is the other half of our solution, the x coordinate. So we would say that our solution set, if we're going with that tedium of set notation, is the set of the point with x coordinate 1 and y coordinate 2. But of course we should check our solution. Plug these coordinates back into both of the original equations and see if we get true statements out. So we ask ourselves, is 2 times 1 plus 3 times 2 actually equal to 8? Well, 2 plus 6, yep, that's 8. And is it true for the second equation, 3 times 1 minus 5 times 2, is that actually equal to -7? Well, 3 minus 10, yep, that's -7, so we did it correctly. And that is the elimination method for solving systems of linear equations. And so, of course, here are some practice problems for you to do. Solve them by the elimination method, show all your work, and of course check your solutions at the end. If you plug them back in and you get a false statement out of either equation, go back and try to find your error and rework it. And we'll check those in class. Thanks for watching.